goes like this. Users, they all add sentences, or they wish to earn certain parts of the page. So if we say xi is the amount of content owned by user I, one measure of xi could be the number of sentences owned in the page. Now the way it is done today is they expect that a user should own at least 50% of the sentence to claim any ownership. Then the utility then is the percentage ownership. It's just xi divided by summation xj, which means what fraction of the whole page is owned by each user. Right? A very simple formulation as of now. But we'll see that this simple formulation can actually lead to some powerful results. Now, if the objective is just to maximize this term ui, right? As you see, it's just a degenerate solution is obtained. Like just make xi go to infinity, because ui is monotonic in xi. So each one just keeps increasing their content in the page just by adding few more sentences. But to avoid this kind of degenerate cases, we put a penalty or a pricing term. So what we find is to make a unit contribution or to write one sentence in a page, there is some effort that's spent by the user. This effort could be the time taken in just writing it up, or the effort spent in learning about a topic, understanding it, and then writing some meaningful information about it on the page. So we represent this effort as beta I, where beta I is the unit, it's the effort taken to make unit contribution. So the total effort spent is beta I xi. If user I is putting in xi amount of content, then the total effort is beta I xi. Then we have a net utility, which is the utility ui as defined in the previous slide, which is this xi divided by summation xj minus beta I xi. So now the objective function becomes, determine xi to maximize this term. And the constraint is xi should be non-negative. Right? And since each ni depends on the other xj's, we can formulate it as a non-cooperative group. Now that ni, the net utility, we can show as a concave function of xi, which means the Nash equilibrium is unique. And we can determine it by using the first order necessary condition. Now this leads to a system of nonlinear equations as given here. So it's the first term is quadratic, and then you have a linear term. Notice that the second term, the ith, xi is missing in that summation. It's normally the best way to solve this is just numerical. Just get a numerical solution which gets this. But we just try to do this, solve this analytically, so that we see what we can obtain in terms of insights. So what we do is we rewrite this in matrix form like this, like what is written here. And then we use matrix diagonalization. So what we do is we just replace x by some p times y, where p is an orthogonal matrix. And so we get a system of equations, quadratic, that can be solved by backward substitution.
So where did the squared term come from? Like you started out with a utility that was like what fraction of the page?
Agreed. It comes from here. So when you do ni by dou xi, you have this in the denominator. Okay. So when I sort of multiply out and do things, you get that summation xj term whole square. So by doing that, I'm skipping the details. What we basically, the way we solve it is replace x as p times y, where p is a unitary matrix, and then this can be written as a system of quadratic equations. Right? The last one is only dependent on xn. The last but one is dependent on xn minus 1 and xn, and the first one is dependent on x1 through xn. So just go by backward substitution, we get a simple closed form nice expression like this. Now this kind of result is what was really powerful, and we could get some additional insights into what drives user behavior in Wikipedia, and we'll see that in a moment. When I go back and obtain the sentence ownership, it simplifies to something like this. The plus indicating that if it's negative, I make it 0. So
somehow people who have too high of a cost just don't participate.
exactly. So if beta I is too high, then their ownership, they don't have any ownership in the page. Now beta I, if you remember, was the amount of effort that's spent in making a unit contribution. So what it essentially says is, to make a unit contribution, if a user has to put too much effort, then that person's contribution won't really survive.
But you assume there is a review standard, right?
Sorry?
Like you assume there exists some review standard, like you put in some content in the Wikipedia, you should pass some review standard, right?
Now, as long as it's not, see that the moderators as of today, they don't go and verify the truth behind what people put in. But
so how can you regulate people claim the beta I?
so beta I, when we go through the empirical data, I'll let you know, there are means of measuring this beta I.
He hasn't told
certain
you how to
cases.
exactly measure it in our model yet. He's just saying there's some amount of effort you put in, that's all so far.
So it means it doesn't matter the beta I, how to get it back.
It does,
So we
but
tried to use some data to figure out what beta is, and he'll show you some results for it. But I think the more important message is sort of what Roy was asking, is that if the beta is sort of below the average effort expended in the page, then essentially whatever you put in goes away.
Oh, I can say that.
I'm sorry, it's a right.
It's
the,
a right.
The
My bad.
cost of
The other way, the other
of
it's a right.
participating is above
Exactly.
average.
Right.
If beta
Yeah,
is
right.
above the average beta,
Yeah.
then that means your content won't survive.
right.
You won't put in the effort compared to people who would cost them less. Right?
Yes.
So there is an average effort that goes into contributing, and if somebody needs more than that average, then they don't survive. If the effort required for that individual is less than the average, then they survive to make contributions in the page. And we will make connections to what this result to trustworthy collaboration, and we'll also see how this relates to combating vandalism later. But what is also interesting is, see, one of the things which users can do is just a frivolous deletion. Somebody puts in a content, I can simply go and take it away from the page. I can just delete it. This formulation takes care of frivolous deletion in a very nice way, because frivolous deletion, it doesn't give me any incentive. When for example, if I delete somebody's sentence, their ownership gets reduced, but my ownership doesn't increase. Right? Because I don't get any credit for deleting. So, but on the other hand, I need some effort in actually making that deletion. So if you look at it, my xi is 0, but my beta I is non-zero. Right? Not xi, sorry, my ui is 0, but beta I is non-zero. So I sort of get negative utility according to this formulation. So what we do is we want to verify our model against some real data. So the details of how we obtain the data is in this, but we pick about 9 wiki pages. These are the titles: Aikido, Angel, Baryon, Board Game, Buckminster Fuller, Center for Disease Control and Prevention, Dartmouth College, Classical Mechanics. These are certain topics for which what happens is, in the way we pick our data is, we have these things available. We look at the time and the type of each edit. And this is an entire log. It's right from the time the page came into existence till today. So
is that like about 10 years?
about 10 years.
Something
Right?
like that.
About 10 years of data. So we have the time and type of each edit. And Wikipedia actually, based on the IP address, people have user IDs, so you know who is making contributions. Sometimes they don't have user IDs, they just go by the IP address of the machine from which the contribution was made. So there are ways of identifying unique users. So for each page we know who are the unique users who contributed to the page. We know exactly what time they did, what kind of edit they did they add content, did they modify, or that can be obtained. And there were 2 manual human assessors who had some inter-rater agreement to compute this effort involved. So each time what they do is looking at the size of the edit and the time at which the edit started, it ended, etc. They compute some kind of effort for each user. So these are the parameters we have: the number of independent users n, the total effort si, the number of edits ei, and the number of sentences owned by each user at the end of the page. You know, as of, you can call it at steady state. So now we compute beta I as si over ei, which is the total effort expended by the user so far divided by the number of edits. So that gives the effort per edit or something. And we also compute the ownership as pi over summation pj. That is the fractional ownership. So now the idea is compare this expression obtained from data to that UI star, the net utility we obtained through the game theoretic analysis, and then see how they look like. So this is what we have for one. We did it for all the 9 pages. I'm showing only 3 of them for simplicity, but we obtained similar results for the others. So what is interesting here is, of course, we see that those 2 bars, one the white bar, the unshaded bar is from the data, and the black one is through the analysis. See, obviously the analysis and data don't match. That's fine, and we did expect it. We didn't really think they would be exactly the same. But what is interesting is the trends are very similar. See, as long as these 2 bars are small, these 2 have some height. The moment this thing changes height, this thing changes height too. Then after some time, this thing goes here, and later this goes a little higher. See, and it's not even that, we cannot always say that the data is more than the analysis, because at some place the data is higher, the value predicted by analysis is lower. In this place, the value predicted by analysis is higher, the one predicted by obtained from data is lower.
Can you kind of repeat, in terms of the analysis is all based on, there's some beta i's.
Yes.
But it's not clear how those are, how they would be created for individuals. Like, what's my beta I? I have no idea.
Right. So this is what.
So.
Yeah.
Yeah.
So in this, there were some 2 human assessors, right, who used some inter-user rating agreement, and they calculated the total effort or scope of every edit that was made on the page. So this they do for every user, and based on this they come up with an average effort that's expended by the user overall, and then they look at the number of edits made by each user. So when I divide this by this, that gives the beta I for user.
Beta is like a unit effort.
It's the unit effort. It's
so they have some measure of the total number of edits, which I think is pretty straightforward. In fact, we're looking at something for the new.
So you can look at the history and see the
exactly.
number of edits.
Yeah. So in fact, we're trying to change this effort. So we're trying to use this thing, right? Perhaps this is not part of the stock. We're trying to use something called the Levenshtein distance. Familiar with that?
Not really.
So Levenshtein distance is a distance measure that is used when you have strings. Like when you give me one page and another page, I can talk about the Levenshtein distance between the 2.
It's an edit distance.
Yeah. So and then we're trying to sort of do something with the logarithm of that. Yeah.
So
that's not
who
the
works
stuff.
on that is Lara Dolich, I think, talked about.
Oh, she did.
Yeah. About like doing compression with edit distances. So basically, though, okay, so you have some data, and from the data, you are estimating the beta I based
Yes.
on looking at how much effort they put in and how many
Exactly.
edits they made.
yeah.
Okay, and then you calculate the
So I put-
OI also from the data.
Yes. OI is the fractional ownership that's obtained from the data, because the data directly tells us this, the number of sentences owned by each user.
Right.
So I calculated pi over summation pj from the data. Then what I also do is I go back here and plug in beta i's, which I calculated from the data, into this expression. And then I compare this with what I have from the data, the OIs.
So you're kind of almost doing more like a self-consistency check. Like, because, like, for instance, you could just be like, I'll look at the OIs associated with a lot of pages, infer the betas and then show us pictures of like, these are the betas of actual people. Like the distribution of betas, right, looks like this because we looked at a bunch of pages based on this model. That's what, and then we could be like, oh. But you're doing something different than that. You're taking betas, which are one thing, and the effort, which is a different thing, and your model links them, and you link each of them to the data and kind of see whether the whole thing holds together.
Yeah, but then he's going to train, he's going to use 3 pages, train his model with that, and then let it operate without knowing anything about the other 9 pages.
Yeah, I'll come to that part.
Yeah, but so now I understand this. What is this plot? Like,
okay, the plot is simple. Like you have about 60 different unique users for this page.
Okay.
So what I do is, from the data I have that pi over summation pj, that is these bars, the empty bars, and then I have the beta i's from the data. I plug in the beta i's to obtain that optimal ownership from our game theoretic analysis, plot that is those black bars here, and I compare the two. Now,
those 2 giant black bars are people who had very high or
huge ownership according to the game theoretic analysis.
Yeah, so they had like very low beta.
Yeah, they are very low beta, exactly. And the same guys, their actual ownership as obtained from the data is here. So which means, in terms of absolute values, the game theoretic model is not exactly equal to what is obtained from the data. But what is interesting is, the trends are matching. So whenever, the plain bar, the unshaded bar rises in height, correspondingly the black bar also rises in height. Right? Another interesting thing, and we observed this for other pages too. Like this is for board games, this has more users. There are like about 150 unique users. And we see the same trend, it's like that step function here. And this is for the page Erin Borokovic.
Do you think this is like a discretization or quantization thing, like that the smallest unit is maybe 1 sentence or something like that? That the units of what people leave in a page, like they're like, oh, it's a sentence or it's a paragraph,
Yes.
and that's why you get these jumps that all these people are at 1 sentence and these people are at 1 paragraph. And those guys are like, they wrote most of it, like that.
I'm not sure if we can model it in terms of sentence or paragraph, but what it essentially says is, all these guys, they all have beta I greater than that average beta, so we are not even looking at them, they have 0 ownership.
Yeah.
Now look at the people who have non-zero ownership. From our formulation, we can show that ui equal to uj if and only if beta I equal to beta j. Right? So that means all these guys have equal betas, all these guys have equal betas, all these guys have equal betas, and all these guys have equal.
Yeah, but now Roy is asking, does it mean that the guys at the very end over there are just 1 sentence?
Like here?
Right? Yeah.
Here?
So it's like 0.2 something.
Yeah, I mean,
Like, why are they all like, all those guys are equal beta?
that's something
Not
even
just
that,
like all, I think it's because of the way you measure it and they all get quantized to 1 unit or 2 units.
Yeah, I think there is some, because remember, if you own at least 50%, you're considered to own a sentence.
right.
Perhaps it is some quantization where they're all equal.
Exactly.
Yeah,
So the exact variation probably comes there if, people who own less, so 40 and 30 are still considered 0 and 60 and 70 are still considered 1. So that could be the reason why it sort of shows up this kind of a state.
You're spelling Brockovich wrong. I think there's 2 typos in it. You're going to use these slides. It's BR, not BOR.
Okay.
And I think it's I'm not sure it's a W, it might be a B. But
Let's check now. I did not catch that.
it's definitely BR.
No, I have a lot of complaints about your equations actually. They're horrible. You need to change them. You need to use a PDF in LaTeX and then perhaps cut and paste it. So what's
In
that?
fact, that's how I got the equations here. I used the PDF and.
No, some of the one equation I saw looked really bad.
Okay.
Earlier on, I showed you.
Anyway, so.
Ellen Brockovich is Brockovich.
Is it B or W?
It says V according to Wikipedia.
I see, yeah.
Yeah. So Erin Brockovich, Brockovich. I think you need to fix that. It's in many places, I think. Okay.
And see, here is some of the key observations. So if you take all the users with non-zero ownership and divide them into something called equivalence classes. So what I say is two users who have equal ownership belong to the same equivalence class. We have very few, even though we might have like 150 users or 60 users or whatever, the number of equivalence classes are like 5 or 6. We observed this for all the 9 pages which we saw. And the other thing is this is what the analysis told us, beta I less than E of beta. And we also found that from the data too. The data also matched this, it satisfied this requirement to have non-zero ownership. And the other, the empirical data validates the analysis. When I say this, I mean in terms of the trends. So what we also thought was, can we get a good correlation between the data and the analysis? So we looked at the Pearson coefficient for all these pages, and it's actually very good because it goes, for some pages it goes all the way to 0.9, 0.7 and so on. Now using this, we tried to do a least squares fit to match the value obtained. So A1 through AN is what we obtained through the game theoretic analysis. D1 through Dn is what we obtained through the data, and we try to see if we can fit a linear function with sort of estimates di hat as rho times ai plus delta. And this rho and delta are obtained by using the method of least squares. So we use these 4 pages, Aikido, Angel, Baryon and Board Game, as training data for this linear fit, and then measure the error on the other 5 pages. And we find that the error is less than like 0.1, which is about 9%, 9 to 10% error. Now, what does this mean in terms of collaboration? See, if we say lower beta I means a user requires lesser effort to contribute, that means we can say that person is a bigger expert on that area, right?
I was going to suggest another thing. It might suggest they're unemployed. If you try to figure out, well, in 2008 or 9, the beta I's were lower, right?
Yeah, that's a possibility.
Yeah.
You can look at
but they have these papers, right? Sort of.
Yeah.
Right.
That's an interpretation.
This particular paper actually, observed this qualitatively. They found that, people who have real expertise on the field, only their contributions actually.
Right, because they realize, they can write a lot
Right.
about this without working too hard, because they know it all.
Right. And Dick Frankel and Marty Cooper validated this fact for me. But then they are also kind of retired.
So what this means is,
another version of unemployed, I guess.
So Narayan says, the experts work on it, right? Validated your theory, but then he points out those guys are also retired. It's just a fancy word for
So two of the people who have been recognized as making contributions to the invention of the cellular system, right? Who won all these highest awards. Both of them apparently had edit wars on Wikipedia. Oh, this is something I found out. And
for the pages for cellular.
Right. Right.
so how that result, the expertise, the experts' contribution surviving the edit wars, what it means is users can try to collaborate with others who have higher expertise. And also, if all the beta i's are equal, we find that, this thing becomes 0 because every beta I becomes equal to E of beta. It sort of says that, you need heterogeneity for collaboration, which was also found in this paper here, which we mentioned. It was found qualitatively. We have a model that sort of quantitatively validates this result. And vandalism. See, vandalism occurs in different forms. People add irrelevant content or offensive content, or sometimes they just delete content ad hoc. Mostly, there are moderators and editors who actually take care of these kind of random additions and random deletions. What we look at it is in this case, in our model, to actually do an act of vandalism takes a lot of effort, because if you have to fight this process of reverting, right? So for a vandal to survive, a lot of effort needs to be put in by the vandal to really to make his act not being detected by the moderators. So that is like a vandal requires actually a high value of data in our model, which is one reason why many pages survive vandalism. That's one interpretation of our model to see how vandalism can be combated. So what we have essentially done is we have come up with the first game theoretic model to model user interactions in Wikipedia. We formulated a non-cooperative game, used content ownership as the utility and effort as the cost, and we validated our model for these pages, and we found how our model can be interpreted for trustworthy collaboration and vandalism. What we are now doing is we have 100 other Wikipedia pages for which we are applying this model against the data to see whether we can get similar insights. So if there are any questions.